What happens if we try to do problem number 1, example number 1 in the ambiguous case notes with law of sines instead of the law of cosines? Remember, that's the one where there are two possible triangles. This is a very common mistake that students make. They see a way to use law of sines to do this problem instead of law of cosines. And there is a way to use law of sines. It's just not as obvious, and most students don't get all the way through it correctly. So let's just see what would happen if you tried to use law of sines. So we would draw a triangle using the given information, and you're trying to find side R. We would need to know angle R in order to find side R. So the first thing you're going to have, but we don't know either one, so the first thing we're going to do is use the given information and law of sines to find angle P. Now, we don't usually use law of sines when we only know one angle, but it is possible to find an angle. So we're going to say sine of P over 10 equals sine of 20 over 5. Now notice I put the sine values on top and the sides on the bottom. That's because I'm missing an angle, so it makes it easier to solve that way. So sine of P is 10 times sine of 20 divided by 5. So P is the inverse sine of 10 sine of 20 divided by 5. And if you do this on your calculator, you'll get an angle of 43.16 degrees. And so that's what angle P is right here, which looks very reasonable. Now, in order to find R, then I'll subtract the two angles I know from 180 to find the third angle. So angle R turns out to be 116.84 degrees when I subtract the two other angles from 180. So now I can use my law of cosines and say R over sine of 116.84 equals 5 over sine of 20, and solve for R. And I end up with one of the solutions. I end up with R equals 13.044, which is the solution that we got the first with one of the parts of the quadratic formula in problem number 1, in example number 1. The problem is, with law of sines, that's the only one I get. I don't get both of the possible solutions. I only get one of them. So my advice to you would be not to use law of sines in a side-side angle situation. Now, if you are curious about could I have gotten all of the correct answer using law of sines, yes, there is a way. So I'm going to show this to you. I'm not recommending this necessarily, but I'm going to show it to you. So there is a way to get both solutions, and this is what you would do. When you get to angle P, you're going to recognize that I could draw this length 5, either here, or I could draw it over here. So angle P could be this big, or else angle P could be an acute angle over here. And what it turns out is that the other possibility for angle P is the supplement of this angle. So I'm going to use inverse sine to get angle P, and then also use 180p for the second possible P. So then I'll have 43.16, or whatever 180 minus that is, 180 minus 43.16, that would be the other possible P. So if there's a different possible P, that means there's a different possible R. So I would have two different part 3s. Okay, I would have a part 3 with this value for R, and I would have a part 3 with the other value for R, and I would get both sides that way. So you can do it that way if you want to. It's just, I think it's a lot more steps, and it's a lot harder to remember the way to do it. When you go back and look at number 1, it's pretty straightforward. You set up the law of cosines, you solve it using the quadratic formula, and you get two solutions, and that's your two sides. Much simpler that way.